Okay students, now we are going to do this activity to demonstrate the effect of force on acceleration. That is the relationship in Newton's second law of motion. For that, I will need this trolley with 3 rubber bands, but I'll be using the rubber bands one by one. For convenience, I have already tied the rubber bands to the trolley. So, we'll be starting the activity with one rubber band so that we give 1 unit of force. So, if we pull with one rubber band, what we need to do is we need to stretch the rubber band so that we can apply the force. So, you can see when I release the trolley, what will happen to the trolley. So, you can see students, when we use one rubber band, that is like applying 1 unit of force. Then what I'll do is I'll be using 2 rubber bands so that there is double the amount of force applied on the trolley. So, as we did before, we pull and stretch the rubber band up to the other end of the trolley. Then we release the trolley. So, you can see how the acceleration changes. So, next what we need to do is we need to apply the force with all 3 rubber bands so that there is a total of 3 units of force. So, all the 3 rubber bands have to be stretched simultaneously together and then we need to release the trolley. So, students, with that activity, you would have seen when we use one rubber band, the acceleration of the trolley is less. But when we use 2 rubber bands, the acceleration increases. And when 3 rubber bands are used, thereby increasing the force 3 times, you can see that the acceleration increases further. So, from this, you can understand the relationship between the force applied on an object and the acceleration that results from the force. Okay students, this is the second activity to demonstrate the Newton's second law of motion. So, we already saw that the force affects the magnitude of acceleration. Now, we will see how mass affects the acceleration of an object. So, what I'll be using is a trolley and 2 weights. You can use any weight that is available at home or you can even use a wooden block. So, for now, I'll be using these 2 as the weight objects. So, first we will do the activity with just one rubber band. I have already attached the rubber band to the trolley. So, what I will have to do is I will stretch the rubber band in order to apply the force. Then when I release the trolley, you can see how it moves. So, I am going to release the trolley now. So, students, you can see just the trolley when applied the force with one rubber band moves with a certain acceleration. Now, I will place this weight on the trolley and use the same rubber band to apply the force. Now, the mass of the trolley has increased due to this object. So, I'll stretch it to the other end of the trolley and release the trolley. So, here you can see the speed with which the trolley moved has decreased to a certain extent compared to the first time. So, now I am going to place the second weight on the trolley. So, we increase the mass of the trolley. So, then I'll use the same rubber band to apply the force. Now, you can see what will happen to the trolley. As you can see students, the trolley stopped at a short distance compared to the previous instances. In the first instance, without any weight on the trolley, that is no objects on the trolley, it moved a longer distance. With one object, the mass increased and it moved a little slower. Now, during the third instance, with two objects on the trolley, the mass increases further and therefore, the trolley moved very slowly and stopped. So, from this, you can clearly observe the relationship between the mass and the acceleration. When we increase the mass, the acceleration will decrease. So, with this, we can clearly demonstrate the relationship between acceleration and mass. That is, acceleration of the trolley is inversely proportional to the mass of the trolley. So, that proves the Newton's second law of motion. Okay, students, now we will do the activity using this blown up balloon to verify the Newton's third law of motion. So, this is the only material we need for the activity and this is a fully blown up balloon. As you can see, I am just holding on to the mouth of the balloon and when I release, you can observe what will happen to the balloon. Using that observation, we can verify the Newton's third law of motion. So, what I will do is, I will just bring the balloon down a bit, right, and I will just take off my hand. So, you can see the observation clearly. So, as you saw, the balloon moves up when I take off my hand. What is the reason for this change or the observation? Yes, you know the reason. When I release the hand, the air flows out of the balloon, that is, the flow is downwards. And this downward force exerts an upward force on the balloon, which makes the balloon to move up. So, as you know, students, Newton's third law of motion says every action has equal but opposite reaction. So, the action is the releasing of air downwards. Therefore, the balloon moves upwards. That is the reaction. And they are both in opposite directions. So, students, you have clearly observed the demonstration of Newton's third law of motion. Okay, students, now let us do this activity to verify Newton's third law of motion. You have already seen one observation for action and reaction. So, this is again another activity where we use a balloon. As you can see, students, we have blown the balloon and the mouth of the balloon is tied so that the air does not escape the balloon. And the balloon is attached to a straw using sellotapes and the straw is sent over the thread. So, if the balloon moves, it can move along the thread with the straw. And you know the reason why we use a straw? As you can see, since the straw is going over the thread, the balloon along with the straw can move easily without any hindrance. So, the activity, as you know, is very simple. I will cut the mouth of the balloon, which is tied now, using a pair of scissors. And when the air escapes the balloon, you can see what happens to the balloon. So, the observation will give you a clear indication about the Newton's third law of motion. Now, I am going to cut the mouth of the balloon using a pair of scissors. So, I will hold it at this part and cut it off so you can observe. So, students, you saw what happened to the balloon. When the air moves towards this side, the balloon moved towards my right side. So, the action of air flowing out was towards my left hand side. and the reaction, the movement of the balloon was towards my right hand side. So as you know, the Newton's third law of motion says every action has equal and opposite reaction. So you saw the action and the opposite reaction. So with that observation, you can understand clearly how the Newton's third law of motion works.